So let's look at an example of one-sided limits. So if we want to find the limit as x approaches 2 of g of x, we want to find the limit on the left, which is denoted by this sign, and the right. And if they approach the same number, that means the limit exists. Therefore, the limit as x approaches a is going to equal to L. So for g of x, the limit as x approaches 2, we want to look at the limit as x approaches 2 from the left of g of x, and the limit as x approaches 2 from the right of g of x. So when it approaches 2 from the left, it means x value is less than 2, which is basically over here. And as you can see, as x approaches 2 from the left, the graph is going to be approaching 3. Then for the limit as x approaches 2 from the right, which means x value is greater than 2, over here, it means that the graph is going to be approaching 2. Now the left and the right limits do not approach the same number, therefore it does not exist. Therefore the limit as x approaches 2 of g of x does not exist. What about the limit as x approaches 6? We first look at the limit as x approaches 6 from the left, and the limit as x approaches 6 from the right of g of x. So from the left, it means x value is less than 6. Over here, we can see that the graph is going to be approaching this undefined value over here, and not this one. So it's going to be approaching 3. The limit as x approaches 6 from the right. That means x value is greater than 6. Over here, as x approaches 6 from the right and goes arbitrarily close to 6, we can see that the graph is going to be approaching 3. So you can see that the left and the right limits do approach the same number. Therefore, the limit does exist. Therefore, the limit is of x approaching 6 of g of x is going to equal to 3. As you can see, this is what we have shown here, that the limit as x approaches a number a, on the x-axis of f of x will equal to L, if and only if the limit on the left of g of x is equal to the limit on the right of g of x.